Hello everyone, I am Kiran from Sri Venkateswara College of Engineering, Bengaluru. Today I am going to discuss one of the topic in analysis and design of algorithm. The topics are insertion sort and the topological orders. In topological orders, I will discuss two methods. Now let's see the insertion sort. Insertion sort is a simple sorting algorithm that works by iteratively inserting each element of an unsorted list into its correct position in a sorted portion of a list. It is a stable sorting algorithm, meaning that elements with equal values maintain their relative order in sorted output. Let's see the algorithm of the insertion sort. Input, you have to take an array of 0 to n minus 1 elements of n elements. Output is of same elements in the increasing or non-decreasing order. And then for loop, you have to apply in that I should be initialized to 1, then it should be to n minus 1, then it will be iteratively execute. Then v is equals to array of I, and j we need to decrement j is equal to I minus 1. Then we have to apply the while loop where in that j should be greater than or equal to 0 and array of j should be greater than v. Then the condition is true, the iteration will be keeps on going. When the condition will fails, then the a of I plus 1 is equal to v condition will be executed, and that will be the sorted array. Here are the steps to perform insertion sort. Start with the first element as the second sorted region, then take the next element from the unsorted region and compare it with elements in the sorted region. Insert the element into the sorted region at the correct portion. Repeat the process until the unsorted region is empty. The sorted region now contains the entire input list. Here is an example for how insertion sort work. Now, suppose you have the array of list 89, 45, 68, 90, 28, 34 and 17. This is an unsorted array. Next, move on to the algorithm. For I is equal to 1 to 6, where we have the 7 elements in this, and then this is we have to divide to two parts as sorted array and unsorted array. Here 89 is sorted array and rest all is unsorted array. We have to keep v is equal to 45 and j is equals to 1, while j, that is 0, is greater than or equal to 0 and 89 is greater than 45. 89 is a of j, that is a of 0, that is 89. So 89 should be greater than 45. If the condition is true, then the while loop will be executed. Then a of j plus 1 is equal to a of j, that is a of 1 is equal to a of 0, that is a of 1 is 89. Then j is should be decremented. J is equal to 0 minus 1, that is equal to minus 1. Then we have to execute the while condition while loop again, where j, that is minus 1, is greater than or equal to 0. This is false. So the loop will come out and execute the array of a of j plus 1 is equal to 45. Then the 45 will be move on to the array at the first element as the first element. Now this is the array where it is sorted and unsorted arrays. Second iteration, for I is equal to 2 to 6, where v is equals to 68 and j is equal to 1, where j is greater than or equal to 0, and this is true. And then next condition is a of j should be greater than 68. Then this is true. The condition will be executed. A of j plus 1 is equals to j, that is a of 2 is equal to a of 0. A of 2 is 89. Then j should be decremented. Then it will be 0. J will be 0. Then we have to execute the while condition, where in the while condition j should be greater than or equal to 0. This is true. And the next condition is a of j should be greater than 68, where for a of j is lesser than 68. Here we have 45 as a of j. Then this while condition will be false. Then it will come out of the loop and execute the condition, that is a of j plus 1 is equals to 68. Now the array sorted array is 45, 68 and 89. Next, the third iteration is for I is equals to 3 to 6, v is equals to 90, j is equal to 2, while 2 should be greater than or equal to 0. Here j should be greater than or equal to 0, and 89 is should be greater than the given v, that is 90. Here the condition will be failed, so it will be directly come out of the loop and execute the another step, that is out from the while loop. It will execute a of j plus 1 is equals to v. So a of 3 j plus 1, that is 2 plus 1 is 3, is equal to 90. Now 45, 68, 89 and 90 are the sorted array. Let's move on to the fourth iteration. For I is equals to 4 to 6, where v is 29 and j is equal to 3. While j is greater than or equal to 0 and 90 should be greater than 29. This condition is true, so it will execute the loop, and again j will be decremented and it will become 2, wherein that j is greater than or equal to 0, and this is true. And next is 89 is greater than 29. It is also true. Then it will execute the condition a of 3 is equals to 89 and j is equal to 2 minus 1. It will decrement the given number, and again it will execute the loop while j is greater than or equal to 0, that is 1 should be greater than or equal to 0 and 68 should greater than 29, that is true. Then a of j plus 1 is equal to a of j, that is 2 is equal to 68. Then j should be decremented and j will become 0. Then again we need to execute the while loop, where while loop in that while loop 0 should be greater than or equal to 0. This is true, and 45 is greater than 29. This is also true. Then it will execute the while conditions and while condition statements, and in that j should be decremented to 0, 0, and here j will be minus 1. Next, the while loop will be executed. In that j should be greater than or equal to 0. Here we have j as minus 1, so this condition fails and it will come out of the loop and execute the condition, that is a of j minus 1 is equals to 21, 29, that is a of 0 is equals to 29. Then the sorted array is 29, 45, 68, 89 and 90. Then we have two more unsorted elements in the array. fifth iteration. For I is equals to 5 to 6, V is equals to 34 and J is equals to 4. Then we have to execute the while condition where J should be greater than or equal to 0 and 90 should be greater than 34. It will be, this condition will be true, and then execute the statements and J should be decremented to 3, and then again while condition will be executed in that 3 is greater than or equal to 0 and 89 is greater than 34. This is true. Then it will execute the condition, it execute the statement A of 4 is equals to 89. Then J will be again decremented. Then while loop again will executed continuously until the condition will be failed. Here now J is uh, J is 0 and then where 29 is greater is lesser than 34. Now this statement is a false statement, so it will come out of the loop and execute the condition, that is A of j plus 1 is equals to 34, that is A of 1 is equals to 34. Now the sorted array is 29 and 34 is sorted in the second position of the array. It is 29, 34, 45, 68, 89 and 90. Next, sixth iteration. For I is equals to 6, V is equals to 7, 17, J is equals to 5. While, while we have to check the J should be greater than or equals to 0 and then A of J should be greater than 17, that is V. If it is true, then execute the statement, that is A of 6 is equals to 90, then J should be decremented. Again, the continuous, it will execute the loop continuously again and again until the condition is false. While we are, when we are executing here, while condition, this is actually, this is false statement where J is here J is minus 1, it is lesser than the 0, and we have to exit from the while loop and we have to execute the statement from out of the while loop, that is A of j plus 1, that is A of j, that is j is minus 1. Yeah, minus 1 plus 1 is equals to 0, then A of 0 is equals to 17. Then the 17 will come at the first position, that is at the 0th index of the array. The sorted array is 17, 29, 34, 45, 68, 89 and 90. Let's see the efficiency of the insertion sort. Insertion sort is a simple sorting algorithm that builds the final sorted array on one item at a time. Its efficiency is based on its ability to efficiently sort small array or partially sorted arrays. Insertion sort has a time complexity of big O of n square in the worst case scenario. Best case scenario for insertion sort, time complexity for insertion sort is big O of n when the array is already sorted. In this scenario, the algorithm will only compress each element with the adjacent element and moves on to the next element. This makes insertion sort highly efficient with dealing with nearly sorted arrays. This is the summary of the insertion sort, and let's move on to the topological sorting. Topological sorting is a method used to order the vertices of directed acyclic graph in a linear order. It ensures that for every directed edge from vertex u to vertex v, u comes before v in the ordering. This ordering is useful in scheduling tasks, resolving dependencies, and optimizing operations. Let's understand the directed acyclic graph. This is a graph with directed edges and no cycles. In a DAG, nodes are arranged in a way that there is a consistent direction of dependencies between nodes. Topological sorting is only applicable to DAGs as it requires a linear ordering of nodes without any cycles. DFS, that is depth first search algorithm overview. DFS is a recursive algorithm that expresses as far as possible along each branch before backtracking. It uses a stack to keep track of nodes to visit and marks each visited node to avoid revisiting them. DFS is commonly used in graph traversal, topological sorting, and finding connection components in a graph. Next, let's move on to the problem. This is the acyclic graph, directed acyclic graph. In this, we have to start from the vertex A. That is, A should be this is the selected vertex, and next A as the adjacent vertex, that is B. And let's let's move on to the B vertex, B as the adjacent vertex E. And then E is the dead end of the of this acyclic graph, and it has no output uh, edge of the E. So E should be popped out first from the stack, and then it will be moved back to B, that is selected vertex B, and it will check whether B has any adjacent vertex. Here now we will see that B as the adjacent vertex as G, B as the adjacent vertex G, and G as the adjacent vertex F. And we will see here F has no adjacent vertex. There is no connection going out from the F. So F we need to pop out next. Here we have E and F we have popped out already. Next go back to G, and we have to check whether again G has any other vertex. No, we don't have any vertex for the G. And then again popped out, this will be the dead end as of now, and G should be popped out, and we have to move towards B, and we have to check again whether there is any edges to the edges which are going out from the B, and there will be no edge going out from the B. As of now E and G are already in the stack, and we have popped out. Next, B will be again popped out from the stack, and it will be move on to the A. Here we have to check whether it has any edge connected to the A. Now we can see C as connected to the A, and next A as the adjacent vertex as C, and C has no adjacent vertex, whereas we have connection to the F. Already we have popped out F from the stack, so we have to move this C also to this. We have to remove the C from the stack. Popped out, C will be popped out. And next we have to go back to the A, and here A we don't have any edges to the A. Then we have to pop out A from the stack, and we have at last D has no connections from this all, and we have to pop out. This is a topological sorting. Source removal method for topological sorting. In the source removal method, we repeatedly remove nodes with no incoming edges from the graph. The remove nodes from the topological order of the graph. This method is efficient for topologically sorting a DAG and can be implemented in linear time complexity. Now this is the DAG graph. Step 1, we need to remove D from the acyclic graph and the topological order is D. Next, we have to remove A because it has no incoming edges for the A. Now A will be removed from the acyclic graph and the topological order is D and A. Next step 3, we need to remove B from the acyclic graph because B has no incoming edges, so we have to remove B. Next, the topological order is DAB. Step 4. Next, we have to remove from the acyclic graph, then the topological order will become DABC. Next, step 4 is we have to remove G because G has no incoming edges from the outside, so we have to remove G and the topological order is D, A, B, C and G. Next, at last we need to remove E and F. First we have to remove E from the graph and next the topological order will become D, A, B, C, G, E and F. At last F will be left from the graph, so F will be directly come from there to topological order. This is the topological order for this graph. Thank you for watching this video.